In Part 5 of Lecture 1, we will look at the parser for the shaper language. Let's take a look now at the parser for the shaper language. The class parser is derived from the class scanner. This means that parser will have direct access to any of the methods and properties of scanner. You'll see here that I have exactly 3 methods that are public, the 2 constructors that correspond to the 2 that we saw with shaper, and also one called proc program. This is where we will begin the process of parsing our program. You'll notice that we have below it in privately proc rectangle, proc square, proc triangle. These are the 3 different commands that we'll be looking to parse. You'll see after this the token and then the token string. In other words, the lexeme, the string that we have that we are going to be getting from the scanner and that we're going to be using to determine what's what. Here you see the 2 constructors for the parser. The first one takes in the number of command line parameters as well as the array of command line parameters. And you'll notice it's going to get these from the scanner's constructor. And then we'll get from this the first token class. We have the same thing for the default constructor. Again, there's an assumption that we will get from this the first token. The first thing that we do in proc program is that as long as the token is not the end of file marker, we're going to see what it is. If the token is rectangle, we process for the non-terminal rectangle. If it's square, we process for that. In both cases, when we return, we get the next token. The third possibility is that we may have the token for a triangle, and we're going to process based on it being the non-terminal triangle. And afterwards, as before, we're going to scan for the next token. There's also the possibility that what we have as a token is something completely different. And in that case, we print that it's not a legal statement, we return the appropriate error message, and terminate the run of the program. Let's take a look at proc rectangle. Now, you'll notice that after the opening comment telling us what it is, and we declare the variables shape, columns, and rows, we also declare a lexeme that we can read in. Now, we don't really need the words wide or long, but if we didn't have them, we would not be able to illustrate an example of type checking. So we have it here for that reason only. We know we have already scanned and found the token rectangle. That's how proc program passed us to this particular recursive method, proc rectangle. After this, we're expecting to find wide or long, and if we do not find one of these 2 tokens, we print an error message to that effect, and then we exit with an error code of 4. If we actually did get wide or long, next we're looking to get the number of columns, and that means we're expecting to get the token number. If that's not in fact the case, we will print an error message that we expected number instead of whatever we found, and then we will return the error code 5 and terminate. After scanning for the number of columns, I have the token by. It's merely a separator, but the grammar requires it because it makes life easier for the human reader. If I didn't encounter this, that would be an error requiring an error message, and then we would terminate. Then we next look for the number of rows, and if it is in fact the token number that we get back, we're fine. Otherwise, we print an error message that we expected that but did not get it, and again an error message. The procedures proc square and proc triangle are in the complete code, which you can find for the shaper language. But they work along largely the same lines. Again, when we are parsing a non-terminal, we have a call to the recursive method that we use for this purpose. If we are parsing a terminal, we scan for it. If we do not find it, we print an error message for it, and then afterwards we move on. Once we have finished parsing, we're ready to draw the rectangle on the screen. Now, you'll notice on this particular slide that all the code is in regular font, not boldface as before. The only code in boldface will be the additional statements that we add to implement the semantic actions that this method requires. You'll see, first of all, here in boldface, that we save the token indicating whether it is wide or long using the variable shape. We then read in the number of columns, and you'll notice that we convert it into an integer. This is important. If the rectangle is long, that means we're going to have more columns than rows. If it is wide, we'll have more rows than columns. Although, if we have the same number of rows and columns, it could be either one. That would be fine. Now we need the number of columns. We still have to get the number of rows. Now we are ready to scan and read in the number that indicates the number of rows. It's a string right now. We convert it to an integer and save it. We're now ready to do the comparison, so we'll see whether we do have a long rectangle as we expect, or we have a wide rectangle as we expect. And now we do our basic type checking. If the shape is supposed to be long and there are more rows than columns, that's a type error. If the shape is wide and we have more columns than rows, that also is a type error, and this is where we would catch it. This is not caught by the parser itself because this is a semantic error, not a syntactic error. After this, we will now draw the rectangle. Drawing the rectangle involves a double for loop, an outer one for each row. We're going to go in, and for each column in that row, we will print an asterisk. At the end of the inner loop, we go to the next line so that the next row will appear in its proper place. We'll have something very similar to this for draw square and draw triangle.